In this video, we will solve a problem on how to find the aggregate demand function from the given IS and LM curves and also the slope. The question is, the equation for IS curve is being given us as y is equal to C naught plus B naught plus G bar upon 1 minus C1 into 1 minus T minus B1 upon 1 minus C1 1 minus Ti. And similarly for LM curve, it is being given us as I is equal to 1 upon M2. We have M naught minus MS upon P plus M1 into Y. Okay, where Y is the income, I is the rate of interest, and MS denotes our money supply, and P is the price level. Further, we are being told that, let us say this term 1 upon 1 minus C1 1 minus T is equal to lambda. Then find the expression for aggregate demand function and sign of the slope. Okay, we need to find out the expression for the aggregate demand function and sign of the slope. Okay, so how can we solve this question? Simple thing what we have to do, we just need to insert the value of rate of interest in this function. Okay, or simply we put our LM function into our is function to get the aggregate demand function. Okay, so then it will become y is equal to, so I will write this. So in place of I will insert this expression for LM. So we have C naught plus B naught plus G bar, which is our government spending, and we are also being told this term is equal to lambda. Okay, so I can write it like this. Since we have here 1 upon 1 minus this thing, so in place of this I can write lambda. So let me write it here. So we have also lambda here minus, so 1 upon this term, again it is equal to lambda. Let me write it here, lambda. Then we have b1. Okay, b1, and the value of I is this term, so let me write it here. We have 1 upon m2. Okay, so let's use the long bracket here. Then we have m naught minus ms upon p plus m1y. Okay, okay, let us rewrite it. So we can write it like this: y is equal to, let's write this lambda on this side. So we have lambda c naught plus b naught plus g bar. Okay, let's multiply this lambda b1 to this term, so we will get minus lambda b1 upon m2 into m naught minus ms upon p plus m1y plus m1y. Okay, then we can further write it like this. So we have y is equal to lambda c naught plus b naught plus g bar. Okay, multiply this term to these terms. Okay, so I can write it like this: minus lambda b1 upon m2 into m naught. Okay, then minus minus is plus. We have lambda b1 upon m2, then we have ms upon p. Again minus into plus is minus, so let me write here minus lambda b1. Okay, so we have lambda b1 upon m2, and we have here m1y. Okay, now let us see which term here is composed of y. Only this term is composed of y. We will transpose this term to LHS. Okay, so we can write it like this. So we have y. Okay, transposing this term, it will become plus lambda b1. Okay, then we have m1 y upon m2 m2. Okay, I have transposed this term to LHS. So we are left here with lambda. We have C naught plus B naught plus G bar. Okay, then we have this term minus lambda again. So we have lambda b1 upon m2, lambda b1 upon m2 and m naught. Then we have this term again. So let me write it here. Plus we have lambda b1 upon m2 ms upon p. Okay, so here we will do one thing. Let's multiply this m2 to this y doing the cross multiplication. So we have m2y plus lambda b1 m1y upon m2 will be equal to, okay, so we have here lambda c naught plus b naught plus g naught. Okay, so here let us again take this minus lambda b1 upon m2 common. So we have minus lambda b1 upon m2. Let's take it common. So we are left with m naught. So it is minus here. So let's write here minus again, because minus into minus is again plus. So we have ms upon p. Okay, I hope I am making myself clear here. Now let's take y common here. So if I take y common, I will be left with m2 plus lambda b1 m1 upon m2 is equal to this term. So I have to write it again. So we have lambda c naught plus b naught plus government spending minus lambda b1 upon m2. We have m naught minus ms upon p here. Okay, now just transpose this term to RHS. It will get reciprocated and multiplied to each of the term. Okay, so we have two terms, this term and this term. When I transpose it, it will get multiplied and reciprocated to each of these terms. So our y, okay, let me use another color. I don't have the lot of space here, so I'm just trying to skip some steps here. So y will be equal to, so if I transpose this here in this term, so it will become m2 lambda upon m2 plus lambda b1 m1, and this we have c naught plus b naught plus g bar. Okay, so I have transposed this to RHS, multiplied to each of these terms. So first I have multiplied to this term. Okay, so we have here this numerator upon denominator. It will become denominator upon numerator on this side. Okay, then again here it will become, we have minus. So when we reciprocate, it will become m2, or let me write it here because it will get messy. So we have minus, okay, I'm just transposing this term here. It will become m2 upon m2 plus lambda b1 m1. Okay, then we have lambda b1 upon m2, and this term m naught minus ms upon p. Okay, so here this m2 and m2 will get cancelled, and we will be left with, so our y will be equal to, y is equal to, let us write it m2 lambda as it is, m2 lambda upon this m2 plus lambda b1 m1, then we have c naught plus b naught plus g naught. Okay, then we have minus this lambda b1 upon again this m2 plus lambda b1 m1. Okay, and this term m naught minus ms upon p. Okay, so this will be our aggregate demand function. Okay, I have solved it for y, so our total output depends upon these terms. Now we need to find out the slope of this aggregate demand function. Okay, now the slope of the aggregate demand function will depend upon the price level. Okay, it will not depend upon any other thing here. Okay, so we have the government spending, it is exogenous here, so c naught, probably it is the autonomous consumption here. Okay, and these are all the autonomous variables here, and only variable which we have here, which is this price. That means our aggregate demand function, its slope depends upon the price level. And what will be the slope of the aggregate demand function? So slope of AD will be equal to simply dy upon dp. Okay, we need to take the derivative of this aggregate demand expression with respect to price and see what will be the sign here. Okay, so in these terms, in the first term we have no p, so its derivative will be equal to 0. Okay, here we have one thing, we have to rewrite it here, but I don't have the space. It will become here, so minus into minus will become plus. Okay, so we have here this term, since we have 1 upon p, if I differentiate it, it will become minus 1 upon p square. Okay, using the rules of differentiation, it will become 1 minus 1 upon p square. Okay, and consequently our slope will be negative. Okay, so since here it gets minus into minus is plus, obviously when I rewrite this expression, so let me write it here. Okay, I don't want you to get confused, so for that let me rub this out. Okay, so I have to rewrite it again. So we have y is equal to m2, so I will not write this term because no, rather I will write it here. Okay, so confused, but so we have m2 lambda upon m2 plus lambda b1 m1. Okay, we have this c naught plus b naught plus g bar, multiplying this, so we have b minus lambda b1 into m naught upon, I am just multiplying this, so we have here m2 plus lambda b1 m1, then this minus into minus will become plus. We have again lambda b1 upon m2 plus lambda b1 m1, because here minus into minus is plus, so we have ms upon p. Okay, now taking derivative of this function with respect to p, that means dy upon dp will be equal to, since no p is involved here, so its derivative is here 0. Here the derivative is also 0. Here we have the p, its derivative is simply derivative of 1 upon p is equal to minus 1 upon p square. How? Simple thing, I will explain it here. So if we have 1 upon p, I can write it like this, p to the power minus 1. I have just transposed this p to numerator, its sign will get obviously changed. So its derivative simply by power function rule, exponent becomes coefficient and exponent is subtracted by 1. So we have minus 1 minus 1, so it becomes minus p minus 2. Again, if I write it like this, minus 1 upon p square. Okay, so I just transpose it again to the denominator, its x sign will get changed. Okay, so our slope will be equal to, as I have told you, it is minus 1 upon p square, so we will get minus lambda b1 upon m2 plus lambda b1 m1 ms upon p. Since this is negative, that means our slope will be less than 0, which is negative. Okay, I hope I make myself clear in this video. So this is the expression for the aggregate demand function, and its slope will be obviously negative. Okay, so it is like this. We have this aggregate demand function, we have output on this side and price level on this side, and its slope is negative. Okay, I hope I make myself clear. Thank you.